Hello everyone, my name is G. Shivaprasad. Rule number 21951-804J9 ECE section. My topic name is Linear Phase Digital Filter Design. What is linear phase in filter? Linear phase is a property of a filter where the phase response of the filter is a linear function of frequency. The result is the all frequency components of the input signal are shifted in time, usually delayed by the same constant amount the slope of the linear function, which is referred to as the group delay. Digital filters with linear phase have the advantage of delaying all frequency components by the same amount. They preserve. Why is linear phase important in filter? Why do we need linear phase filters? Digital filters with linear phase have the advantage of delaying all frequency components by the same amount. They preserve the input signals phase relationships. This preservation of phase means that the filter signals retains the shape of the original input signals. It is well known that casual finite impulse response filters can be designed to have linear phase. However, infinite impulse response IIR filters can have linear phase only in the non-casual case. Mitra 2006, Vaidyanathan 1993, Vaidyanathan and Chen 1998. The phase response can be 0 or pi. Character of linear design. If a FIR filter is linear phase if and only if its coefficients are symmetrical around the center coefficient, that is, the first coefficient is the same as the last, the second is the same as the next to last, etc. A system that accurately preserves such relationships is said to be phase linear. A properly designed FIR filter is an example of a linear phase filter. If some one group of frequencies experience a different delay from others called group delay error, it will color the sound or cause audible artifacts. Why are linear phase important? Linear phase filters will preserve the wave shape of the signal or component of the input signal to the extent that's possible, given that some frequency will be changed in amplitude by the action of the filter. Linear phase shifted occurs when the phase response of a device is linearly proportional to frequency. In actual practice, many electrical and electronic devices will delay some frequency more than others, creating nonlinear phase shift distortion in signals consisting of multiple frequency components. Application requires explanation. The signal processing is computationally cumbersome and appear to offer no advantages over linear phase FIR filters. Consequently, when an application requires a linear phase, it should be an FIR filter. In signal processing, a finite impulse response FIR filter is a filter whose impulse response to any finite length input is of finite duration because it settles to 0 in finite time. FIR filters can be discrete time or continuous time and digital or analog. Do all filters have linear phase? No, FIR filters are not always linear phase. The acronym FIR only tells you that the impulse response is finite in duration. Nothing more and nothing less, so called minimum phase. FIR filters are not linear phase. In previous lectures, we have discussed how the pole and zero location determine the magnitude, and phase out the DTFT on an LSI system. In this brief note, we discuss three special cases: all pass, minimum pass, and linear phase system. Note that the system above has a pole at z equal to a and a 0 at z equals to 1 by a star. Which is better, FIR or IIR? The advantage of IIR filters over FIR filters is that IIR filters usually require fewer coefficients to execute similar filtering operations. That IIR filters work faster and require less memory space. FIR filters are better suited for applications that require a linear phase response. You also might use a square wave to measure space linearly. Square waves are generated easily and have a normal crest factor of 1. The phase linearity is defined as the maximum deviation from a straight line of the plot of the phase varies versus frequency. The measurement is performed in steps. Is linear phase better? The linear phase will remain more of the body of the combined sound, but may not possess the same depth or dimensionality depending on what we are going for. One may be preferable to the other. Phase shift is part of the natural way we perceive depth, so it's not like one approach is inherently better. Why DFT is preferred? The discrete Fourier transform DFT is one of the most important tools in digital signal processing. For example, human speech and hearing use signals with this type of encoding. Second, the DFT can find a system's frequency response from the system's impulse response and vice versa. It is expensive. The signal bandwidth of the input signal is limited by ADC and DAC. The bandwidth of the digital filter is much lower than an analog filter. How digital FIR works? IIR filters are typically designed basing on continuous time filters functions. Once the transfer function has been chosen, different filter structure allowed to implement the filter, be it in hardware or in software context. Difference equation of 3-tap FIR filter can be expressed as the direction from structure and transport form structure of 3-tap. FIR filter is shown in figure 4, figure 3 2 respectively. The transport form 3-tap FIR filter is implemented at 1200 kHz frequency using VHDL codes. Transform of filters. Just as long filters are designed using the Laplace transform, recursive digital filters are developed with a parallel technique called the Z transform. The overall strategy of these two transforms is the same. Probe the impulse response with sinusoids and exponential to find the system poles and zeros. 3-tap fill filters. Context 1. Difference equation of the 3-tap FIR filters can be expressed as the direct form structure and transport form structure of 3-tap FIR filter is shown in figure 3, figure 4 respectively. The transport form 3-tap FIR filter is implemented at 1200 kHz frequency using VHDL codes. As a simple tip, an FIR filter is linear phase if and only if the impulse response is symmetrical. It doesn't matter whether it's odd symmetric, 2n plus 1 taps, symmetric about the middle one, or even symmetric, 2n taps symmetric about the middle interval. If an FIR filter is non-symmetric, then it is non-linear phase. Linear phase EQ. Linear phase EQ uses a different underlying technology to channel EQ. that preserves the phase of the audio signal. Phase coherency is always maintained even when you apply extreme EQ curves to the sharpest signal transcends type 1 symmetric sequence of odd length, type 2 symmetric sequence of even length, type 3 antisymmetric sequence of odd length, type 4 antisymmetric sequence of even length. Digital filter coefficients. The filter coefficients are the coefficients of the difference equation. If your filter is an FIR filter, then the filter coefficients are the values of the impulse response. If you have an IIR filter, then the filter coefficients are not the same as the impulse response. Thank you.